Hey everyone, it's Mr. Canfield. So I am filming this in the middle of class because I forgot to get it done when I had time when students weren't in the room. So I'm gonna go through this whole packet, drop some knowledge for you. Probably watch this at 1.5 times. No, just kidding. All right. So acronym for trig. SOHCAHTOA. Yeah, okay. So the sine equation is sine of our angle is equal to opposite over hypotenuse. Cosine of our angle is equal to adjacent over our hypotenuse. Tangent is equal to opposite over adjacent. Explain in your own words how you know where the hypotenuse in a right triangle is. Well, any right triangle, I drew that upside down by accident, believe it or not. The right angle, I'm gonna use multiple colors here. Oh wow, look at this. The right angle always points to the hypotenuse. If you have a right triangle and you have some angle theta, opposite always comes from wherever the angle's pointing. That's opposite. So in this case, if I drew it again, here's theta. So if we want adjacent, what's up? Oh, okay. Looks like Frankie got his problem fixed. People like to steal his pencils. All right, so that's still opposite over here. So then that makes this adjacent. And if, oh, wait. And if you're like, why isn't that adjacent up there? Remember, because the right angle already claimed that. That's our hypotenuse. It already has a name. Paper on your desk. We're working through this. And I'm filming the video right now because I forgot to do it earlier. So if we want to label these, here's our angle. That's our theta. I'm dumb. That's theta right there. This is our opposite. So like on this one, there's our opposite. On this one, there's our opposite. On this one, here's my right angle, right? So here's hypotenuse. Here's hypotenuse. Here's hypotenuse. And then so for all these, I know where my opposite is, I know where hypotenuse is, so that means this has to be adjacent. And adjacent is it's the non-hypotenuse side that's touching the angle. So here's my adjacent, here's my adjacent. All right. Let's keep going. For the following true triangles set up, do not solve the correct ratio equations for sine, cosine, and tangent. All right, this is sine alpha. There's alpha. That's our opposite. Then there's our hypotenuse. That means that's our adjacent. Well, we know sine is O over H, right? Okay, well, O is 8. H is 17. 8 over 17, done. Cosine of alpha is A over H. That's A, that's H, 15 and 17. Alpha, tan is O over A, right? So it's O over A, so 8 over 15. It is that easy. On these ones, people get confused because it says sine A and we don't see an A, but it's because that's the A. This is angle A. So now let's name everything. There's opposite. There's my right angle, so there's hypotenuse, so then that's adjacent over there. So sine's O over H. That's 27 over 45. A over H, so 36 over 45. That one, 20, op over adjacent, so 27 over 36. And these are absolutely simplifiable. I don't have a calculator on me. Oh, I'm gonna need a calculator. I'll be right back. Make sure you watch your language. Oh, all right. I apologize about YouTube demonetization. Oh, I'm not monetized. It doesn't matter. So like for these, we could do 27 over 45, math, enter, 3/5. You know, or you could, learn how to simplify fractions by finding common numbers to divide out of them. That is a legitimate way to do this. Like, what I mean is, 27 over 36, those are both divisible by 9. So 27 divided by 9 is 3. 36 divided by 9 is 4. It's 3/4. And then neither of those have anything else that they can have in common to divide out. So if I do 27 over 36, you'll see that that is 3/4. All right. Now, this says solve for x, missing sides in the following right triangles. So it's just asking for a singular side in each one. And naming is always our first step with these. So there's H, there's O, then that's A. Okay, so which situation do we have? Well, I don't care about H because there's no label there. I care about A, and I care about O. So what uses A and O? No. A, no. O and A, there we go. So we know tangent of our angle, 68, is equal to O over A. That's x over 14.5. And if I look at our possible ways to solve this, when the number is on the bottom, we just multiply both sides by 14.5 by the bottom number. And cancels it, brings it over. And so there we go. Just a reminder, make sure you push the mode button at the beginning and make sure you're in degree mode. I do have other classes that use radian mode, so 14.5 times, you can put times in there. If you don't put it, the times is included automatically. And I got 35.9 degrees. Because the 8 after the 8 tells it to round up. All right, and then this one.
This is the formula for finding opposite.
Yeah, I'll do it. Yep. So on this one, here's our angle. Let's see. So we care about x, right? Well, that's O because it's across from the angle. There's the right angle. Across from that is hypotenuse. So we got O and H. O and H. So it's sine. So we can say sine of our angle is equal to O over H. That's x over 2. So another one where the number's on the bottom, we can just swing it over. 2 sine 54 is equal to x. And we get Canfield. This isn't degrees. This is a side length. You were just talking about side length. I'm sorry. So here I get a side length of 1.61, which is 1.6. It's not degrees, it's a side length. Huh. All right. Sorry if that was confusing. Let's look at the next one where we find a side length. So here's my angle, so that's opposite. That's H, because it's across from the right angle. I think I saw one in here. I got a pen. You want a pen?
Yeah, I'll take a pen.
Yeah, all right. Almost done the packet, and that's when that question comes up. Interesting. All right, so that's O, that's H, that's A. Okay, so here's our 44-degree angle. Wait, I don't care about O. There's no marking on it, so I care about H and I care about A. That is H and A, H and A, H and A, H, no, H, cosine. So cosine of our angle is 44, cosine 44 is A over H, 11 over X. And remember, so when the number's on the bottom, it swings over. When X is on the bottom, these two trade places, and you get X is equal to 11 divided by cosine 44. And Mr. Canfield, just remember, it's going to give you a side length. So my side length here is 15.3, because the 2 gets told to round up by the 9 next to it. So where is that in our triangle? Is it here? No, it's where X is. It's right here. This is 15.3. All right, on this one, we got, here's our angle. So X is going to be away from it, so it's our opposite. And then I was going to say this is adjacent, but look here, this is our right angle. This is our hypotenuse. So we have O and H, that's sine. So sine of 18.1 is equal to O over H. So now we'll just, it's on the bottom again, right? So when it's on the bottom, we just swing it over. 17.9 sine 18.1 is equal to X. So 17.9 sine 18.1, I got 5.6. All right, we're already almost done this packet. All right, next order of business. This one says find the missing angle. Here's my angle, so that's opposite. There's my right angle, so that's hypotenuse. So this is A. Let's see, I've got O and I've got A. That is O and A. O and A, tangent. Tangent of our angle. We don't know our angle. O over A, 20 over 6. Julian, can you watch your language, please? So, if I want to find the angle, we use inverse tangent. The technical thing that's happening here is we're using inverse tangent of both sides like that, and it's canceling over here. But the only thing you really need to remember is when we need to find the angle, we use the inverse trig button. And so all you're going to have to do thank you. Food. So we need the second trig, that is second tangent. That's how you do it. You push second and then the trig button you're using. 20 over 6. I got it. This one is an angle. Whenever we use the inverse thingy, it gives us an angle. I got 73.3 degrees. All right, let's do our next one. Let's see, our next one, we got 5 and 13. Here's our angle. Let's see, that's our opposite. That's our hypotenuse. So there's A. Okay. So A and H, that's cosine. Cosine theta is equal to A over H. And so we'll just use inverse cosine, 5 over 13. So instead of pushing cosine, we'll push second. Get the little arrow show up. Inverse cosine, 5 over 13. So we get about 67.4 degrees.
That's not the actual item. That's just the light that colors that.
All right, so in this one, it's the same thing, right? There's our opposite side over there. I always want to say this is adjacent, but be careful. There's our right angle. This is hypotenuse. So we got sine. Sine theta is equal to opposite over hypotenuse, 9 over 17. So theta is equal to inverse sine 9 over 17, which is 31.9. Oh, okay, this one's interesting. 31.965. So that's going to round to the 9's going to round up to a 0. So I would say this is 32.0 degrees.
Okay, stop that.
The reason why I leave the 0.0 there is to show I rounded there. That's why it says 0.0. That's the decimal place that I stopped at. And this last one here is tangent again. So tangent theta is equal to 4/3. So theta is equal to inverse tangent of 4/3, which everyone knows is 53 degrees. All right, so cool. So we could use trig to find this third side here because I have the 60-degree angle and I could pick two of these and use sine, cosine, or tangent and figure out which one to use. Or it's a right triangle. I could just use a squared plus b squared equals c squared. Remember the two legs, the things touching the right angle, are a and b. So I can say 8 squared plus x squared is equal to c squared, 16 squared. That's 64 plus x squared is equal to 256. Remember, when you're squaring 16, you get the little squared thing, or 16 times itself. That's what squared means. So if I want to find x squared, well, I'll subtract the 64 from both sides. I get x squared is equal to 192. And then if I want to find out what x is, now we introduce a square root. Second square root 192. We get the lovely 13.9. So same thing here. I can use Pythagorean theorem. These are both touching the right angle, so 10 squared plus 10 squared is equal to x squared. So that's 200 when you add those, because it's 100 plus 100 is equal to x squared. So we'll take the square root of that, and we will get 14.1. All right. On to the final page. Kelly is flying a kite with an angle of elevation of 70 degrees. So angle of elevation is the angle that it makes with the ground. So that's that right there. The string on the kite is 65 meters long. Well, if you imagine, here's Kelly, whee! Here's the kite, whee! Where's the string? This is the string, 65. How far is the kite above the ground? Is that above the ground? No, that's above the ground. That right there is x. So now it's a simple setup, right? Here's our angle. There's opposite. There's our right angle. That's hypotenuse. O and H. Wait, that's sine. So I can say sine 70 is equal to opposite over hypotenuse. So we'll multiply both sides by the 65. 65 sine 70, and let's see, 61.1 meters. Let's see, a ladder is 30 feet long. Where's the ladder here? The ladder is leaning against the building. Reach up 27 feet up a building. So that's 27. What is going to be the angle between the building and the ladder? Where's the building? Where's the ladder? Here's the building. Here's the ladder. Where's the angle between them? Bop. We'll call that theta. And so now we need to name it, right? Well, let's see. That's opposite. We don't have opposite. Okay. We do have hypotenuse. And that means we have it. So we have adjacent and hypotenuse. That is, yes, that is cosine theta equals a over h. 27 over 30 inverse cosine to finish it up. Second cosine, 27 over 30. I get 25.8 degrees. The end. All right. Down here, you make up your own word problems. Okay. Also, should have gone back. I realized in my handout I say something a little bit different here, because I don't have these pictures drawn. Oh, I didn't do let's see. the key phrase. So when you get your test, if you at the top, you can just be like, Julian. So you put that somewhere on your test. I mean, like, I don't know if that's actually gonna happen or not, but like they say it's gonna happen, right? Okay, have a go. Bye.